Okay, good day, grade 9s. We are going to be looking at just quick revision this week, revision of grade 8 geometry. So just before I get started, if you have any questions, of course you can reach out to your teachers and ask, but if you want an immediate response or an immediate answer to a question you might have, then it'll be a good idea to have a look in your grade 8 maths books, because like I said, this is revision of grade 8 geometry. Okay, so we're going to get started quick. Before we look at the different types, I just want to remind you of rules when it comes to geometry. Very important the way you set up your answers. Okay, so when you're setting up your solution, you need to set it up in a very specific way, because with geometry, it's very important that you always state your reason. Okay, so as soon as you've got a geometry question, anything that you write down that you know to be true, you need to tell the person who's looking at your work, how does you know that it's true? So that's where the reasons come in. Okay, so to set up your work for this, you're going to start off by writing an equation. Okay, and the equation obviously will depend on the scenario. You'll look at your scenario, you'll see what you need to find, and you'll use the rules that we're going to remind you of now to set up your equation. And next to your equation in brackets, you're going to put the reason that you knew that that equation was true. And I will remind you of these reasons. You have to use the reasons that I show you. Okay, you're not allowed to paraphrase them. You're not allowed to write them in a different way. You must write the reasons in the exact way that I'm going to show you. Okay, so you'll write your equation with a reason next to it in brackets, just like we did with Pythagoras. And then underneath your equation, you will solve your equation. Okay, and then also just very important is anything that you think, any little logic step that you make in your head, any reasoning that you do in your head needs to be written down. Okay, so very important with geometry, you write down everything. You never assume that the person looking at your work will just know what you were thinking. We can't read your mind. You need to write down everything that goes through your head. Okay. Now we can actually get started. So geometry is split into three parts. We've got straight line geometry. Okay, let me actually write this down. Okay, so there's three parts. We've got straight line geometry. We've got triangle geometry. And then we've got parallel line geometry. Okay, now these are from grade 8. This is the grade 8 geometry you learned. There is more geometry. You're also going to do quadrilaterals. You're also going to do a little bit of Euclidean geometry this year. But from grade 8, these are the three types of geometry. So these are the three videos you're going to be watching this week. Okay, so we're starting off with straight line geometry. Okay, and the first so we're starting off with straight line geometry, and there are three laws in straight line geometry. Okay, so we're going to number them. Okay, guys, so the first of the three straight line laws or rules is that if you have a straight line, so this is something straight out of primary school, if we've got a straight line, you guys know this from grade 6, 7, and again in grade 8, that this whole angle over here, a straight line angle, is 180 degrees, right? We know that. So if I were to take this straight angle, that is 180 degrees, and split that up into multiple different angles. So if I take this big 180 degree angle and I cut it up into parts, so let's say I put a line there and another line there. So I've split this into three separate angles here, right? I've got angle, let's call it angle A, angle B, and angle C. Then logically it makes sense. If you take something and you cut it into three parts, if you put those three parts together, they should give you the original whole thing. So this A, B, and C together should give me 180 degrees. So that is our first law. Okay, that I will write it out in words now, but mathematically it says that A plus B plus C is equal to 180 degrees. And now for this section, remember you need a reason for every statement. So your reason for any time you use this law, your reason is angles on a straight line. Okay, so we draw a little angle thingy like that. So it's angles on straight line. That is our reason, and you need to learn your reasons. You need to know them off by heart. So here is our first reason. Second reason if you include Pythagoras. Okay, so in words, what this law says is it says that adjacent, now I'll explain this word in a second, adjacent angles on a straight line are, now here's another fancy word, supplementary. Okay, adjacent angles on a straight line are supplementary. So just quick, this adjacent, okay, that word adjacent, this just means that we're talking about angles that are next to each other. Okay, so angles that are next to each other are considered adjacent. Okay, another way of thinking of it is angles that share a vertex or share a point, share a corner. So this is a vertex here, and these three angles all share that vertex. So we can say angles that are next to each other or angles that share a vertex or a point, a corner. Okay, so that's what adjacent means. And this here, supplementary, should know this from last year as well. Supplementary means that they add up to 180 degrees. Okay, just a little side note, nothing to do with this law, but there's another word that sounds like supplementary but means adds up to 90 degrees. Okay, and that is complementary. So supplementary means adds up to 180 degrees. Complementary means adds up to 90 degrees. Okay, so here's our first law for straight lines. If you have a straight line, a straight angle, and you split it into parts, it could be 3 parts, it could be 2, it could be 5, it could be any number. But if you split it up into parts and you add all the parts together, it'll take you back to 180 degrees. And your reason, which you need to learn off by heart, is angles on a straight line. Okay, so that's our first rule for straight lines. The second rule is my favorite one. The second rule is vertically opposite angles. Okay, so number 2, vertically opposite angles. Okay, now just quick vertically opposite angles. I'm just going to write down here next to it how you recognize it. Very easily recognizable. You'll see an X shape. Okay, there'll be an X shape in your diagram. So let's quickly draw the X shape so you can see what I mean. If we have two lines that cross each other, that's what I'm talking about. Okay, so if you have two straight lines that cross each other like that, that is the X shape. And this X shape tells us that this angle over here and this angle over here are equal to each other. And it also tells us that this angle over here and this one over here are equal. So the angles that are opposite each other are equal to each other. Okay, that's what this law says. The angles that are opposite each other are equal to each other. So let's call this angle A and angle B, and let's call this angle X and angle Y. So if we were to do some maths with this, if we were to write mathematically what the relationships are here, then it would be that X is equal to Y. Okay, vertically opposite angles are equal to each other, and it also means that A is equal to B. And for this, our reason is vert op angles. Okay, so vertically opposite angles is what this one is. So that is our reason here. Again, you need to learn this reason. Okay, very important that you know your reasons off by heart. So that's our second reason. And then just in words, for those of us that prefer it that way, what this law says in words is that angles that are opposite each other are equal to each other. Okay. I'm just realizing this is looking a little bit messy. Way too many colors, and I was aware that I'm going to fix that if I add more colors. Okay, just so that we can see where the headings are. Okay, so angles on a straight line. That's our first important law. Second important law is vertically opposite angles. Okay, the X shape. And now for our third important law, this one doesn't come up as often, and usually you could use one of the other two laws in the place of this one, but some people like this one, so I'm going to show you anyway, or so you need to know. Okay, so the third one is angles around a point. Okay, so angles around a point, this has to do with the angle that you learned in grade 6 and 7 that is called a revolution. Okay, so if we quickly draw ourselves a revolution, remember a revolution is basically just a dot. It's saying that we start somewhere and we went all the way around, and that whole thing, that whole journey all the way around added up to 360 degrees. Okay, remember that's a revolution. So we're going to use the same logic here as we did for angles on a straight line. If I take this 360 degrees and I split it up, okay, so let's say I take this 360 degrees and I split it so that I form an angle there. Okay, see there I've got an angle, and let's do another line over here. So there I've got another angle, and there I've got a third angle. You see I've split it into three angles here. Let's label them, angle A, B, and C. If I take those three angles A, B, and C and I add them together, then logic dictates that that should give me 360, because I took a full revolution and I split it into three, so the sum of those three things should give me back my full revolution. So when we have angles around the same point, angles around a point, that tells us that the sum of all of those angles will give me 360 degrees. Okay, the value of a revolution angle. And our reason for this is angles around a point. Okay, so the angles around a point. Again, we need to learn this reason. Okay. And just again in words, we can write down what this law says. It says that the angles around a point add up to 360 degrees. Okay, the angles around a point add up to 360 degrees. Okay, you must pause me there if you're not done, because I'm going to go on to the examples now. Okay, so first example is going to be this one here. Okay, so here's example 1. Quickly copy it down. We need to determine the value of m, and we are given this straight line here, line PR, and then we've got a line SQ and QT intersecting there at that point Q, and they want us to determine the value of m. So if you look at the diagram, you can see m is that angle and that angle as well are both in terms of m. Okay, so it means that they depend on the value of m. So looking at this diagram, we've got three things currently that we know about geometry. That is, angles on a straight line add up to 180. It's that vertically opposite angles are equal to each other, and it's that angles around a point add up to 360. So I don't have angles around a point, right? This Q is not an angle. Capital letters are the names of points. So this point is called point Q. Okay, so we do have a straight line. We don't have any vertically opposite angles here. So if we look at our straight line, we know that all of this together should give me 360 degrees. Oh, whoopsie, sorry. 180 degrees. Angles on a straight line add up to 180. So to set up our answer, we know what logic we're using. We're using the fact that these must add up to 180 because they're on a straight line. So when we set up our answer, we start with the equation. The equation is that my three angles, 70 degrees, 4m, and m plus 10, oopsie, must give me 180 degrees when I add them together. And I know that because I use the fact that I have angles on a straight line. Okay, now we're going to just go ahead and solve our equation. So first off, we know a few different equations now. We know linear equations, exponential, quadratic, inequalities. So first off, let's identify our equation. It's a linear equation, so we know how to solve that. We're going to get m on the left by itself and the numbers on the right by themselves. Okay, so the 4m and the m are staying where they are. On the right, I'm going to have 180 degrees minus that 70 degrees minus that 10 degrees. Okay, I can simplify both sides. So on the left, I'll have 5m, and on the right, I'll have 100 degrees. And hopefully, we all know how to deal with this. To isolate that m, this means 5 times m, so we do the opposite, which is to divide. So we're going to divide both sides by 5 to get rid of the 5 there by the m. Okay, so divide both sides by 5. My 5's cancel here, which is why I did it. So that's what I wanted to happen. And I get m is equal to 20 degrees. 100 divided by 5 is 20. Okay, and we are done. So we set up our equation with our reason, and then we solved our equation after identifying it as linear. Let's just quickly write that here for ourselves. This is a linear equation. That's why we solved it using this method. If it were quadratic, we'd have to solve it using the quadratic equation method. Okay, here is question 2. Okay, we need to determine the values of y and z. Usually when they give you more than one variable to find, so like they've done here, y and z. So if they've given you more than one variable to find, then it's usually in your best interest to do it alphabetically. Okay, it usually means that in order to find z, we first need to find y. Okay, so it's a bit of a hint of the order in which you should do it. So we're going to do this alphabetically, which means we're going to start with y. Okay, so let's look at our diagram. Now, before we even attempt to tackle the question, what I'd like you to do is, if you look at a question and you see that X shape, that means vert-op angles, I want you to go ahead and highlight it. Okay, so I see I've got an X shape here. That line and that line form vertically opposite angles because they make that X shape. Okay, they tell me that this angle and that angle are equal, and they tell me that this angle and this whole thing here are equal. Okay, so the opposite sides of the pink lines are equal. Now, we've said we're going to try and do this alphabetically, so we're going for y first. And can you all see that this is going to help me? The fact that this and this are equal will help me to find y. I can set up an equation with y's in it. So I'm going to go ahead and do that. I know that this whole thing, which is y plus 2y, it's both of those angles together, is equal to the angle opposite, which is 120 degrees. And I know that because they are vert-op angles. Okay, now I just have to solve for y. So I'm going to skip ahead. Hopefully you are fine with solving this equation. So y plus 2y is 3y, and then we'd divide both sides by 3, and we would get y is equal to 40 degrees. Okay, you should be able to solve that equation. Okay, next up, so we found y, we must still find z. So looking at z, there are lots of different ways we can solve this one. The way I'm going to go ahead and do it is that I see this straight line, right? That straight line there. That whole thing should be 180 degrees. And we know that this portion is 120. So it'll help us to work out that portion which has z in it. Okay. So I can say that z plus 35 degrees. Okay, that's this angle, z plus 35. Plus this angle here, which is 120, must give me 180 degrees because I have angles on a straight line. Okay, and now we're going to go ahead and solve for z. So z will be equal to 180 minus 120 minus 35. which is, what's that, 60 minus 35 is 25. We get 25 degrees for Z. Okay, and that's it. Your worksheets are on OneDrive, or your worksheet rather, you're doing activity 1 today, is on OneDrive. Please do reach out if you need help, and good luck.